Hey there, my name is Akshat Madan and I work as a developer relations engineer at Maxim AI. In this video, we will be understanding MCP, that is Model Context Protocol, some main components of the MCP architecture, benefits of it, and how it is different than traditional APIs. But before we dive deeper into the MCP, you need to understand what LSP is, that is Language Server Protocol. It was created to standardize how code editors like VS Code, Sublime Text, or Atom IDEs communicate with language intelligence tools. You must have experienced some features like autocomplete or syntax highlighting, refactoring, and error checking in your IDEs. So most of these modern code editors like VS Code or Sublime or Atom, they communicate with the language server using JSON remote procedure calls. This language server receives the small part of the code that the user has written and helps us in auto-completion of it, syntax highlighting, refactoring, and error checking. In addition to this, the LSP decouples the language features from the editors, allowing shared language servers, which means one language server can serve to many clients. Here clients are nothing but your IDEs. So now you understand what LSP is, which is a very significant protocol for many use cases. But when your end goal is to create autonomous end-to-end agents, then MCP, that is Model Context Protocol, can help you in a much better way. So what exactly is this MCP? So it is an open protocol that standardizes how applications provide context to LLMs. What is context? So let's take an example of software development itself. So whatever code you have written in various files of your project, that can act as a context to your LLMs. Think of MCP like a USB-C port for AI applications. Like your CPU has a USB port, you can plug a mouse, keyboard, printer, any peripheral device to it, and it works without any problem. Just as USB-C provides a standardized way to connect your devices to various peripherals and accessories, MCP provides a standardized way to connect AI models to different data sources and tools. Different data sources, I mean, it can be a local database, it can be your file system. Tools, for example, you have written a software and now the code of that software needs to be pushed to the GitHub. That task can be performed by a tool which pushes code to GitHub. Now, as soon as you have pushed the code to GitHub, you might want to push an update to your Slack channel. That can be performed using a Slack tool. So you can here see that if you want to create an autonomous end-to-end software development agent, you will definitely want your AI model to communicate with various data sources and tools. Unlike LSP, MCP uses JSON RPC 2.0 for communication. As you can see in this diagram, we have an LLM which is Claude Sonnet 3.7. Then we have an MCP which is just like an adapter over here, and it can communicate with GitHub MCP server, it can communicate with Slack MCP server, and both of these MCP servers can further communicate with various tools attached to them. Now just summarizing what we just learned, MCP helps us build agents and complex workflows on top of LLMs. An agent is created when you connect external data and tools to your LLM. And MCP just acts as an abstraction layer for all of these complex workflows. MCP provides a list of pre-built integrations, which we are going to see just in a minute. Flexibility to switch between different LLM providers. So if you check out mcp.so, you can find some awesome MCP servers and clients built by the community. You can see we have an MCP server for Slack, Puppeteer, Browserbase, Cloudflare, and we also have for GitHub. And if I search, let's say AWS over here, you can see many folks who are contributing to this community, they have built their own MCP servers for it. So this can be really helpful for you. You can check this out. Now coming back to the topic, this is a very high level architecture diagram to understand MCP architecture. First of all, we have MCP host, which can have multiple MCP clients. These clients can be IDEs or various tools. Then we have bunch of MCP servers. Now this MCP server can also further act as a client. Host, that means the clients, MCP clients, communicate with MCP servers using the MCP protocol. Now further, if we go ahead, you can see that we have various tools, data sources. These data sources can be local, just like your file system, or they can be remote databases like MongoDB or PostgreSQL. In order to communicate with a remote data source or tool, you need to again use web APIs. But as an end user, we don't have to worry about it. MCP has already taken care for us. You can see we also have certain tools like GitHub and Slack, and again MCP server needs to communicate with these tools using the web APIs. So in order to summarize the components of an MCP architecture, we have MCP host, which are just like programs like Claude Desktop, IDEs or AI tools that want to access data through MCP. Then we have MCP clients which stay inside the MCP host which are just like protocol clients that maintain one-on-one connection with the MCP servers. Then we have MCP servers, which are lightweight programs that each expose specific capabilities through standardized model context protocol. Specific capabilities means they will be performing a very dedicated task. That task can be pushing the code to GitHub. That task can be creating a new ticket on Jira. Then we have data sources, which can be either local, just like your local file system, or they can be remote data sources also. External systems available over the internet, which will be accessed through APIs that MCP servers can connect to. Now the final question is, what exactly are the differences between traditional APIs and the MCP? Can we use traditional APIs also for building autonomous agents? The answer is yes. If you are ready to implement all of the traditional APIs as tools for your agentic architecture, you can do it. But MCP simplifies it for you, saves your time, make it very efficient so that you don't need to worry about the communications happening between various components and you can focus on the end goal of the agent. Now let's see the differences. First of all, the purpose. MCP is an AI-powered contextual processing, dynamic information retrieval, real-time adaptation architecture. In simple terms, we can say that MCP is AI-enabled, which makes it smart and helps us to build agents. Whereas the traditional APIs are just dedicated for data exchange between systems, just like CRUD, create, retrieve, update and delete, or microservice communications. The next point is context awareness. MCP retains and understands the context across interactions. It persists the information from the past, which can act as a context for your next step. Whereas traditional APIs are stateless, each request is independent of the previous request or the future request. They do not persist data. That means we cannot store information as context for our intelligence system. The next point is data handling. MCP works with structured and unstructured data both. It can also handle JSON, XMLs, DBs, plus it can also handle text, images, LLMs and PDFs too. Whereas traditional APIs can only work with structured data, JSON and XMLs. It takes the data as request body in the form of JSONs or XMLs, which is structured, and also returns the data, which is called the response, in a structured format itself. The next point is communication model. MCP is event driven and handles streamings via WebSockets and gRPC. Whereas traditional APIs are mostly request response focused. They can also use gRPC, but at the end the communication will be happening in the form of request and response itself. For communication model, we don't have much differences. They both are somewhere using the same communication model. The next point is processing. MCP is AI driven. It helps in decision making with real-time adaptive learning. As I told, it can persist the data from the past, which helps the overall agent architecture to learn from the past. Whereas traditional APIs are predefined and they work on rule-based operations. That means the schema for the request and response are fixed. The request method is also fixed. That means if the call is get call, it won't be accepting the request body as it happens in a post call. So everything in traditional APIs is fixed and predefined. Coming to the next point, which is extensibility. MCP can integrate with APIs, databases, LLMs and local models, as we already saw that it can talk to external data sources, which can be remote or local. Whereas the traditional APIs are limited to API endpoints and predefined schemas. The next thing is the use case. MCP is AI driven, helps in code completion, debugging and workflow automation. That means you can easily create an end-to-end agent that can help you in overall software development, not just syntax highlighting or auto suggestions. Whereas traditional APIs can only work with CRUD operations, authentication and data retrieval. I hope you learned something new in this video and now you have some knowledge about MCP. We at Maxim excel at agent evaluation and observability. You can log on to evals.new or get maxim.ai to get started. See you in the next video.